There it goes. Okay. So let's get our notes out. Come on, this should not be an overwhelming task. Miles is back there. Dan. Kelsey. No. Okay, so some of this is review. Tell me what you know about this. What do you remember about this? We are going to graph this, and we are going to label all asymptotes and intercepts. So what do you remember from when we talked about this a long time ago? I can't cancel anything. When you have adds and subtracts, then you either cancel it all or not at all. So unless those were the same. So if I had something like x plus 1, x plus 2, over x plus 2, x plus 3, that I can cancel. I'm canceling the whole parentheses, but I can't cancel part of it, right? No. Right. I know why you're thinking that. First of all, there's nothing wrong with that denominator. When I multiply top and bottom by something, it's because I have a problem. So maybe I have something like this. That is a problem because I can't have a radical down there. But in this case, there's nothing wrong with that. That is totally okay. Tell me about what happens if x is 3. And everything falls apart. You cannot have a 0 in the bottom. So you have a vertical asymptote at x equals 3 because the denominator can never equal 0. So where do vertical asymptotes come from? The denominator cannot equal 0. And then I see I have an x over an x. So my horizontal asymptote is 1. X over x, 1. Now, will this fraction ever actually equal 1? No, because if you plug in a number, like let's plug in 1,000,000. If we plug in 1,000,000, the numerator is 1 more than 1,000,000, and the denominator is 3 less than 1,000,000. But if you compare those two numbers, isn't it about the same? I mean, if you have $1,001,001, isn't that almost like having $999,997? They're about the same. That's why we say 1. These don't really count. So right there, that's how I get y equals 1. We did that at the beginning of the year. I don't know if you remember that, but we did it. How do I find intercepts? Well, if I plug in 0, what do I get? If I let x be 0, what do I get? I get negative 1/3. So I'm going to plot that point right here. 0, comma, negative 1/3. That is called my y-intercept. What number will make the numerator 0? The numerator. Negative 1. That is my x-intercept. All right, so let's recap, because we're not going to spend any more time talking about where these things came from. So let's Where do the vertical asymptotes come from? Denominator equals 0. That's sure where they come from. Oh, look at him. He's going to write this down because he knows he's got to remember it. Doesn't matter. Just write it down. Vertical asymptotes come from the denominator equals 0. Where do horizontal asymptotes come from? Boxing in your x's. If that had been a 2x over an x, then the asymptote would be at y equals 2. Where do y-intercepts come from? How do I get a y-intercept? I let x be 0. I plug in 0 for x. And where did the x-intercept come from? The numerator. What makes the numerator 0? Yep. So that's where everything comes from. Now, that we talked about all that before. Now we have to actually draw this thing. So see these two dots right here? They're going to be connected. So I'm going to go out on a limb here and say that's what I got. Have you ever seen that shape before? Oh yeah, you have. It's one of your BFFs. Which BFF kind of has that shape in it?
Exponential.
Well, the exponential looks like this. It does not have two asymptotes. The exponential has one asymptote. Which BFF has two asymptotes? Reciprocal. What does a reciprocal look like? Doesn't it have a piece that looks like this? And then it has what else? Another piece that looks like that. This, the reciprocal function, remember, is a fraction. This is a fraction. It's got numbers stuck into it, and we know that those numbers just move things around. So instead of your asymptotes being where they were in the old days, now your asymptotes have moved because of the numbers that are in the top. Okay? So the next one. All right, what do you think we might be first with this? So, Braden says let's factor it. So what did I need to make? X plus 1, x minus 1. How about the bottom? Take out a 2, and then x plus 2, x minus 2. This is going to be a bigger version of this. It's got more going on. Tell me about my vertical asymptotes. Remember where they come from. What about my vertical asymptotes? They come from the denominator. So aren't there going to be two of them? -2 and +2. Vertical asymptotes come from the denominator. Perfect. Let's look at the original problem. Is there a horizontal asymptote? Yeah. Horizontal asymptote comes right here. X squared, 1x squared over 2x squared. What does that reduce to? 1/2. So my horizontal asymptote But if you do it here, that puts zeros in all over it. There's gonna be a little work involved. I like to go back to the original problem, because if I put in zeros, don't I just have -1 over -8? Which is 1/8. So one more time. Vertical asymptotes come from the denominator. Horizontal asymptotes come from comparing the highest powers of your variable. So 1x squared over 2x squared. X-intercepts come from the numerator. And the y-intercept comes from plugging in 0 for all of your x's. Okay? Now we're going to draw the picture. Tell me your thoughts on that. All the important stuff is in here, now I need a sketch.
Gotta be parabola.
Gotta be a parabola in the middle. I agree with Jimmy 100%. At least some kind of parabolic shape in there. Beautiful. How about the right side of the picture? Well, here's a piece of important information. You know that your reciprocal function has this shape, right? That's the shape it has. Any function that is a fraction is going to have that kind of behavior on the outside of its asymptotes. Now, the middle part in here, that's up for grabs. This time you've got a parabola, and that's great. It'll be other things other times. But out here on the right side, I either am going to have that shape or that shape. Those are my only options. Which one do you think it is? Do you think it's the top one or the bottom one? It has to be the top one. Can you tell me why it has to be the top one? Because if it were the bottom one, what would I have to have right there? Another x-intercept. I don't have an x-intercept there. So if I don't have an x-intercept, I can't cross the axis, so it cannot be this. Similarly, over here, it's either that or that. That's it. Those are your only two options. Which one is it? The top one, because you can't cross the axis. So there is a picture of the function. All right, now we got another easy one. I say easy because it doesn't have all that stuff in it. Alright, here we go. We're going to sketch it first and then we'll answer the questions. We'll talk about all this questions. But right now, we're going to sketch it. So tell me what you know. Give me something to put into my picture. What? Where? Where? Where do I put my vertical asymptote? X equals 2. X equals 2. Vertical asymptotes are what makes the denominator equal 0. Basically, solve your denominator, and that's your vertical asymptote. X equals 2. Perfect. All right, what else? Give me something else I know. Horizontal asymptote is at 1. Y equals 1 because we have x over x. 1 over 1. Right? Something else I know.
Intercepts.
Where? X-intercept is -3 because x-intercepts come from basically solving the numerator. What makes the numerator 0? That would be my x-intercept. Alright, one more thing. What else do I have? A y-intercept at negative 3x. How did I get that? I let x be 0. Based on that, you should be able to draw a picture. What do you think about that? Does that seem reasonable? And then I need another piece on that side. These things are going to have multiple pieces. What's the piece on that side look like? This ring.
So they always recirculate.
Always some version of yours. Now, let's answer the questions. We are going to find the limit as x approaches infinity of this problem. Now, where is infinity? Where is x approaching infinity? That way. This is your x-axis, and here we are approaching infinity, right? So basically, what you're being asked in this question is, as I draw my curve further and further to the right, what is happening to it? Is it going down?
Yes, it is.
It's what?
It's approaching 1.
It's approaching 1. The limit is 1. It is approaching 1. That is exactly what's happening here. As you go farther out, infinity, as you go farther out, the curve just keeps getting closer to 1. Done. That's the answer to the question. Now, what about the other way? It says, what happens as you go to the left? To the left. You're still approaching 1. Now, is there a difference between this approaching 1 and this approaching 1? What is it, Alden?
One's getting clearer.
Exactly. So this one, and I know I'm right under the TV, so I'll put it over here. But this one is approaching 1 from the top. So we'll put a little plus sign on it, because as Alden said, that tells me that I am getting smaller. I'm actually getting smaller. I'm coming in from the top. This one, the y values are actually getting bigger, coming in from the bottom. So that doesn't mean positive 1. This is positive 1. This means coming in from the top of the picture. This means coming closer to 1 from the bottom of the picture. All right. Now, next one says, find the limit as x approaches 2. So let's talk about these two, the last 2 questions. First of all, x is 2. What's happening when x is 2? When x is 2, I have an asymptote. This question is saying, this one, the one with the plus sign, is saying what happens as I get closer to 2 from the positive side. So that would be the right side. What is happening to my curve as I get closer to 2 from the right side? What's happening? Positive infinity. And then what does this one say? It's still approaching 2, but it's approaching from the left side, from the negative side. So what happens as I approach 2 from the negative side? What's my curve doing? Negative infinity. When you approach a vertical asymptote, okay, I'm a vertical asymptote. Curves you can't touch a vertical asymptote, all right? I'm untouchable. So when the curve comes in, what are its choices? As it's getting closer and closer to me, it's going up to positive infinity, or it's going to go down to negative infinity. That is all that can happen at a vertical asymptote. You go up or you go down. In this case, we're going up on one side, down on the other side. All right, we're going to do another one. I'm going to erase all this. Anybody have a question about it? Okay, here we go. Without my help, see how much of this picture you can get drawn. So the curve is 2x plus 1 over x plus 2. How much of this can you draw without my help? Go for it. You don't have to answer these questions on your own, but see if you can get the picture drawn.
Yeah. Yeah.
All right, let's talk about what Mr. Confident has done up here. First of all, is this vertical asymptote in the right spot? Yeah. This vertical asymptote is in the right spot. Is his horizontal asymptote in the right spot? Thank you. His horizontal asymptote is in the right spot. Would you all agree? Y equals 2?
Yeah.
Look at his intercepts. He said his y-intercept is 0, 1/2. Because when he plugged in zeros, he got a half. And then he solved the numerator, set it equal to 0, said what makes this equal 0? And he got negative 1/2 for his his x-intercept. I think all that's perfect. So then he connected these dots and got this. And then he almost forgot, but then he remembered that he also has a piece up here. Because these have 2 pieces. Well, maybe more than 2. But always at least 2 on either side of the asymptote. So are you okay with that picture? I think that's fine.
I don't understand how you got this y-intercept,
Plug in 0.
or the x-intercept.
Solve the numerator. Now we have to answer the limit questions. What is this saying? This says what happens to the picture as we go that way. So what happens to the picture as we go that way? We're getting closer to 2. And we're coming in from the bottom. What does this say? What happens to the left? Well, we're also getting close, going left, going this way. We're also getting closer to 2, but that one's from the top. Right? Now this says we're approaching negative 2. Forget that for a second. We're approaching negative 2. What happens at negative 2? We have a wall. We have a wall. This says what happens as you approach the wall from the right side, the positive side. What is the curve doing as we approach the wall on the right side? Negative. And then this says we're approaching the wall from the negative or the left side. So what happens as we approach here's our wall, we're approaching from the negative side, the left side, what's happening? Positive. Yes, yes. Now, you have to be careful because if you have more than one asymptote, you're going to have that behavior, and they might not be opposite necessarily, but primarily, yes. Okay. You are perfect. Now we're ready for the next problem, though, that's going to introduce a little bit of a wrinkle. Let's take a look at this guy. All right, how are we going to start this problem? This is another little bigger problem. We're in a factor. So the top will be x plus 3x minus 3. How about the bottom? What would the bottom be?
3x plus 9.
3x plus 9. X plus 3. 3x plus 3.
I did too.
We can cancel, can't we?
Yes.
And what does that mean? We have a hole in the picture. You do remember something. We talked about all these asymptotes and things back when we talked about holes. If you cancel out an x, some kind, you're going to have a hole. Where do you think that hole is going to be? Where x is
It's gonna be negative
Negative
2.
where x is negative 3.
Hey, you feeling bad for X?
And then we'll fill in that negative 3 right here. So I will get negative 2.
Yeah.
So on my picture, I will put a nice open dot, a hole in the picture at negative 3, negative 2. And then I'll put in all the rest of my stuff. So, am I gonna have a vertical asymptote? No, no. If you don't have a denominator, and I know I have a denominator, but I don't have an x in the denominator. If you don't have an x in the denominator, you are not gonna have any asymptotes. Alright? This problem has no asymptotes. No x in the denominator means no asymptotes. Okay. Do I have any intercepts? What would make my numerator 0?
That 3 would make it 0.
A 3 would make it. What do I get if I plug in 0?
Negative 1.
Negative 1. That is supposed to be a straight line. This is a straight line because this equation is the same as that. And that is y equals mx plus b. The intercept is negative 1 and the slope is 1/3. But Mrs. Ford, why isn't it a reciprocal function? Because it's not a fraction anymore. There's no x in the denominator. It's just a little line with a hole in it. Oh, that one's terrible. That is supposed to be a straight line. That is really bad. That's a straight line. Stay focused. We got a few more to do. Number 5, pretty easy. I think you got this one. What are we gonna do first with problem number 5?
We are going to factor.
And how will this guy factor?
X plus 5 minus
Odds, what do you think?
Plus.
It should be minus 5 plus
Oh,
1.
come on.
More than 5.
It matters. You gotta get it right. It matters.
5x plus 4.
We can take a 5 out.
Which and
And then we have x plus 1, x minus 1. Now, that 5 that we took out stays in the problem. Don't just lose it somewhere along the way. It stays. It's in the denominator along with your x plus 1, x minus 1.
But we can cancel.
But we can cancel. So x minus 5 on top and 5 x minus 1 on the bottom. So everybody catch up. Can everybody follow to that point?
yes, and.
Before I forget, I'm gonna plot my hole. Now where will it be?
Negative 1.
The x will be negative 1. plug that in right here. Do not try to plug it into the original because it won't work. It'll give you a phone. You gotta plug it in here. I got -6 over 5 times -2. 6 times 3/5. Is that what you said? 3/5. So at -1, 3/5, I have my open knot. Are you okay with that? Boys and girls? Good? All right, give me some other stuff. Here you go. This is where you are. Tell me what else I have.
You're gonna have 5
And x is a point on the x-axis called an x-intercept. I got one at 5. You are exactly right. That comes from the numerator. It comes from the numerator. You can. I like to do that. If I put zeros in, I just get 1, don't I?
Oh wait,
One.
you just negative 5 just 1. Okay.
So I like to do that. You will get the same answer if you put zeros in here. You get -5 over 5 times -1. That's 1, okay. What else do I have? Horizontal asymptote. I always go back to the beginning for that. Where is my horizontal asymptote? 1/5. 1/5. That's the winner. 1/5. Why is it 1/5? X squared over 5x squared. Where's my vertical asymptote? 1. Not gonna be different. It's exactly what you've already seen. Can't you see that? All right. Kindergarten's over. Ready for the big time now. Take a look at the next one. Now, it starts the same way as all the others. So what do you think we're gonna do first? We're gonna factor anything that factors. So I guess it's just the top. And how will it factor? +4 +1. And that's fine, but do you notice that nothing cancels? So that means we just won't have a hole in this picture. Do we have a vertical asymptote in the picture? X equals 2. Do we have any x-intercepts in the problem? -4 and -1, so we actually have 2 of them this time. Can I find a y-intercept? Plug in zeros. What do we get? -2. Before you start connecting any dots, there's something missing. What's missing would be the horizontal asymptote. But remember, Horizontal asymptotes happen when you have problems like this. So that horizontal asymptote would be 3/2. Or if you have something like this. There are no x cubes on top. So that horizontal asymptote would have to be 0 divided by 4, which is 0. This is trouble because this one is x squared over no x squared. What happens if you try to make that fraction 1 over 0? Is that fine? Is that fine? When the power on top is bigger. Are you listening, Jimmy? You're kind of zoned out here. When the power on top is bigger, there's no horizontal asymptote. Instead, there's a slant asymptote. How do I find my slant asymptote? To find my slant asymptote, I am literally going to do this division. So I am going to take 1, 5, 4 and divide it using my synthetic division by 2. To find your slant asymptote, you do the division of the problem. When do I do this? When the power on top is bigger. So what happens when I divide? Here we go. Now, in the last little part of the chapter, that number was always very important to me. That number is the remainder, and I always wanted it to be 0. Where slant asymptotes are concerned, we don't care. That is not part of our issue. This is our slant asymptote. What does this say? X plus 7. So your slant asymptote is the line y equals x plus 7. So I'm going to come over here and I'm going to graph that line. I'm not a very good line drawer, but I'm going to try to draw that in there. That is the line y equals x plus 7. It has a y-intercept of 7 and a slope of 1. Negative 7. Because I can, what?
The 7 is just taking the second one.
This is x squared,
Yeah,
so this is x plus 7.
yeah.
Yeah.
That's what.
Now I'm ready to draw my picture.
That is
So
confusing.
I got a thing that looks like this. Any idea where the other piece is? Actually, right up here. Tiny, well, it's not really tiny, but it's 3 ran out of room. The whole section up there. Now this is 40. Whoa, how did you know this? Well, first of all, if you have one vertical asymptote, you're going to have 2 pieces of your picture. We've seen that already, a left side and a right side. So there have to be 2 pieces. Isn't this piece on the left side already? So that's it, there's no more over here. I need something on the right side. So it's either that little thing, or it's something like this. Can it be that? No, because it can't cross the x-axis. So therefore, it has to be that piece up there. All right, let's let that digest a minute, because we're gonna finish with one more of those. Number 7.
That we divided by came from the power.
No, and from this,
Okay.
yeah, I'm dividing my numerator by my denominator. So that 2 came from there. How do you want to know that problem 7 is going to have another slant asymptote? The numerator power is bigger. Kids, anytime the numerator is bigger, you are going to have a slant asymptote. You can find that first. Let's go ahead and find that first this time. Doesn't matter, you have to find it. How do we find our slant asymptote? You do the division. So what goes in the box? -2. Did I do that right? Remember, the remainder is out of it. Don't care. What is the equation of my slant asymptote and y equals what? Just x. X plus 0? Just x. So that is my identity line right here. This is my slant asymptote. Do I have a vertical asymptote? -2. If you've got a denominator, you have a vertical asymptote. If you have an x in your denominator. Can I do my y-intercept? Yeah, because how do you do a y-intercept? You plug in zeros. 0, 0, 0. I'm left with -3. Now, what about my x-intercepts? I need to do something to find those. What do I need to do? Factor that. I never factored it. X plus 3 minus 1. So I have an x-intercept at -3 and at +1. Now I got to do this one with that. So, do you have any thoughts on what it looks like? This one kind of does that. Would you agree with that? And the other side looks like that. One more time, some of you still look like deer in headlights. One more time, vertical asymptotes come from the denominator. Horizontal asymptotes asymptotes come from matching up the powers. But if the denominator is smaller than the numerator, you're not gonna have a horizontal asymptote, you're gonna have to do a division. With the sum. X-intercepts come from the numerator, and y-intercept comes by letting x be 0. Your homework, 2.6, is due on Monday. It is 2 of these problems. And that's it. Hands-free drive is coming up, so please check your
Ooh, I got plus,
But I give me 15. That's your point. So you just think you're doing it. I had like
You are wasting time. Do some math.
I just clicked.